And turn your camera off, Cody. You can turn it back on when I'm done recording. There you go. This is pretty interesting, guys, if you're looking at this, but the November 2020 climate summary, where we usually always look at Muskegon just since that's what's closest to us. But our average temperature was about 6 degrees above normal. Remember those 70-degree days early on in November? So that helped to boost the average highs up there. And then our precipitation was much below again. So we actually had more sunny days. I think it was the third sunniest November since the 1800s. Usually November is a pretty, right here, 52% possible sunshine compared to 28%, which is normal. So almost double the sunshine than a normal November, which is always good. But precipitation, rain was about 1.5 inches less, and snow was down by about 5 inches. Usually we have 6 inches of snow in November for normal. So that was a little bit lower too. So it's always interesting to look at the climatology stuff. All right, here is the agenda today. We're going to look at La Nina and El Nino, and then watch a little El Nino from Dr. John Neese, and then you'll just have a quick air masses and fronts worksheet. So we're nearing the end of this unit on air masses and fronts and the different ones that affect us in Michigan and the United States. So that's what we'll do today. Okay, so I'm going to start with this. Actually, we'll start with John Neese. So just watch this with me.
I've been putting this off, but it's finally time to have the talk. Yes, that talk. The one about El Nino. And let me start with what El Nino is not, courtesy of Saturday Night Live from 1997.
I am El Nino. All other tropical storms must bow before El Nino.
Despite what Chris Farley implies, El Nino is not a storm, tropical or otherwise. Instead, it's an anomalous warming of the waters of the central and eastern tropical Pacific Ocean, typically from South America to the international dateline and within about 10 degrees of the equator, the area roughly shown here. During an El Nino, those unusually warm waters provide extra heat and moisture to the atmosphere, fueling extra instability, rising air, and more thunderstorms than usual in that part of the tropical Pacific. This animation starts back in mid-October and shows the departure from average of ocean temperature, the oranges and reds that girdle the equator from the shores of northwestern South America westward across the Pacific. They represent water that's 4 to 8 degrees warmer than average. That's the fingerprint of the ongoing El Nino, which is quite strong compared to El Ninos from the recent past. Now, since this is all happening thousands of miles from the U.S., what's the big deal? Well, unlike Las Vegas, what happens in the tropics doesn't stay there. Instead, the impacts ripple into the mid-latitudes. Here, I'll focus on the northern hemisphere. First, the warming in the tropics increases the temperature difference with latitudes farther north, and that strengthens the so-called subtropical jet stream and increases the chance that juicy storms will dump rain in the southern U.S. and even California. Farther north in the Pacific, a persistent upper-level low tends to dominate the Gulf of Alaska during El Nino winters. And as surface storms spin around that mother load, their counterclockwise circulations pull relatively mild air unusually far north into western and central Canada and even the northern U.S. So El Nino winters there tend to be less harsh than average. Only a few El Ninos in the last 50 years were as strong as the current one. Here's a look at sea surface temperature anomalies during two of those, 1982-83 and 1997-98. As before, orange and red indicate warmer than average waters. From a predictive sense, it's reasonable to ask whether we can use what happened during past El Nino winters to project this winter, sort of analog forecasting like we do in our long shot segment. So here's the average temperature anomaly across North America in meteorological winter, December to February, during 3 previous winters when El Nino was as strong as it is now. Yellow and orange indicate warmer than average by 3 to 6 degrees. And you see the relative warmth in western and central Canada and the northern U.S. that we talked about before, but also notice that warmth even extended into the eastern U.S. during those past strong El Nino winters. December so far in Pennsylvania has certainly followed that pattern, warmer than average across the state. And I have a feeling Fred has similar news in the extended forecast. Next.
Okay, so listen, don't be confused by that because that video was from a couple of years ago, but I like it because it does explain well what an El Nino winter looks like. Now, the reason I say don't be confused is because we are actually in a weak La Nina type setup. And remember, El Nino is warmer than average temperatures out here. But if you look at this map now, this is the map from May, you can see cooler than average temperatures at the equator. So when you have cooler than average water or ocean temperatures at the equator, that's a La Nina setup. And that's what we're in now. So this one's real quick. This will explain how La Nina affects us. With El Nino, we have warmer than normal temperatures with La Nina. And because it's a weak La Nina, I don't know how much it will affect us here, but it does affect the path of the jet stream, which you know when the jet stream is below us, we have that cooler air mass coming down. So here's La Nina right here. Okay, so if you look at this right here, the entire model or the entire forecasting system is called the ENSO, the El Nino Southern Oscillation, or ENSO. And this right here, red means warmer. So this would be an El Nino type setup, warmer than average temperatures at the equator. And it should go into a La Nina setup with the next part of this video right here. Okay, so here's the La Nina part, and this is actually what's affecting us now. And then pay attention too, during La Nina, they'll talk about more hurricanes in the Atlantic. This was the busiest, one of the busiest, if not the busiest hurricane season we've ever had. All right, so just a little intro there. Hopefully you learned a little bit of something when you do hear those words that we're in a La Nina or an El Nino season, how it will affect our winter. And again, we currently have cooler than average temperatures out over the oceans near the equator. So that results in a weak, because they're just slightly cooler, a weak La Nina for this winter, which if you remember the winter forecast from a couple of weeks ago, that would mean near normal temperatures and a little bit wetter than normal, which could be rain or snow, hopefully more snow. Okay, so here is the assignment. Let me share this with you. Actually, I'm going to share this one right here. This is just a little review from what we've already done. So here's those air masses again that affect the weather in the United States. Remember in Michigan, we're affected by these continental polars. Just a review again, remember the air masses are symbolized by where they come from for the first letter, either over air or water, and then the temperature or precipitation, or how cold or how warm they are with the second letter. So continental polar, cold and dry, and the maritime tropical, warm and wet, or warm and moist, are the two main ones that affect us here in Michigan. And you can see the other ones because that's one of the learning targets. You can see all of the other ones that affect us here in the United States. So Faith Wilds heading down to Florida. Yeah, you got that maritime tropical there. Hopefully some warmer air, hopefully not as wet, because you want warmer, and it's usually humid down there, but you want to be able to lay out down there. So warmer and not as moist down there. Okay, and then last thing for your assignment today, and it shouldn't take very long. That's why I talked a little bit longer today. If you guys go into classwork and the assignments to turn in, the assignments that are graded, mine's the top one that's due tonight. And then there's two things. There's the article or the worksheet that you'll read through. And then the questions are on here, but I want you to type your questions onto the Google Doc that's attached. So you'll type your questions into this one right here. And it's broken down into sections just like the worksheet is. So you'll read about cold front and the air masses behind cold front, and then you'll just list the 6 things that you learned about the cold front, the 4 things about the warm fronts, 4 things about the other types of fronts. Remember, there's the occluded and the stationary, and then just turn this in when you're finished. So again, you'll find the answers right here. It starts out talking about the different air masses and how they're labeled. Don't worry about the matching part. I didn't include that in the Google Doc. Actually, you can match them on your own. So maritime tropical, you should have an idea of the type of characteristics of an air mass that forms over water in a warm area. And then the answers to the cold front is in this section right here.